Hi there, and welcome to another episode of Mr. Ed Codes. And in this episode, we're going to make grass for our fireflies that we made in a previous episode. You can see the grass waving behind me. It's pretty tall there. Let's look at it here. It's still pretty tall. In this object, you can adjust the height of the grass. You can adjust the way that it moves. There's lots of variability to this object, and it uses a recursive tree algorithm to make a single blade of grass. And then we have an object that will produce a patch of grass, basically. It's just going to make all of this grass here. And you can set the population of blades to whatever you want. Pretty exciting. It's not hard to do, so let's start that right now. We're going to start with the new sketch in p5.js. Make the canvas the available window width and height. And we're going to set the background to black. And that's how we're going to start this program here. We need one global variable that's going to hold the object that makes the patch of grass, and we're going to call that grassy. You can call it whatever you want. Maybe I lack a little bit of imagination, but it's going to help it stay straight in my head. In setup, pretty easy. We just are creating one instance of this object because this object contains all the grass that we need. The object that I'm creating is a function, so we're going to put new. We're going to set that function, that object, equal to this variable grassy. Should be grassy, right? I think I'm just going to call it grass because I just noticed in my code that I declare the variable grassy and then in setup I assign grass. I'm not sure how that happens, but it seems to work in the program, so I'm just going to make it consistent so everything's cool and official. So let's change that to grass. A little less, I don't know. It seems a bit more formal, doesn't it? So that's all of the setup. And we're going to use the keyword new to say this is a new object. It has lots of variables in it. It could be a class, it could be a function. And then we assign that here, and I'm calling that function yard. So before I get started any further, let's just make that function right now, or let's start to make it. So now we have our function yard. It doesn't have anything in it yet. It should have a method in it for making the grass, so let's put that in there. We're not going to drop anything in this yet, and let's make that function inside a function look like it's supposed to. Okay, that should work better. So now if I run this program, everything should work so far. And it does. Okay. Well, at least there's no errors. We're ready to move on to draw. It's real simple. We make our background like we did to start, and we're just going to call that method inside the function, the one that we said this.update. We're going to attach that to grass with the dot syntax. So the object in grass has a function in it called this.update. We're calling it in draw, and then whatever code we put in here is going to happen then. When we instantiate our object, when we create it for the first time, anything that it needs to be is going to be in this section of the function right there. It's the instantiation part of it. There's lots of different ways that you can set up functions depending on how you want to use them. This seems to be the most common application in my experience of just doing hobby coding. It's how I learned to do them. Maybe there's better ways of doing this, but this is just the way that I learned on my own and from a few other people. So in our function we need some initial state variables. And since this function holds a lot of a lot of units, like there's many blades of grass in this function, I need an array to hold each one of those blades, and then I can make the blade of grass and associate its states that it needs to be made by with the element in the array. So let's declare all of our array variables. I could probably do this with a single array with just a set of the variables that I need, but I don't want to do that because then you got to keep track of index values and elements, and it gets kind of crazy. So we're going to use an array for each one of our variables that we need to tell a blade of grass how to be a blade of grass. The very first thing we need is a position. Where is this blade of grass in its patch? So in order to figure out where an X position is. We're going to look at the screen. We're going to divide it by the number of blades of grass that we want on that screen. And then when we make a blade of grass, we're going to just move across the screen by increments of proportions of the blade. So say you have a screen width of 100 and your blade is 10, a width of 10. Well, then you're going to move 10, 20, 30, 40, and you're going to drop a blade of grass at each one of those parts. So that's where we're going to get our X value for how to make where this blade of grass goes. So in our function, we need an array to hold that. We're going to call that this.grass. I don't want the blades of grass to all move in unison. I want them to have some fluidity to them. I want them to have some uniqueness. Maybe a breeze is hitting this part of the patch of grass and it's hitting another direction in a different part of the patch. And maybe there are layers to this patch of grass. So I'm going to be using Perl and noise to achieve this organic movement. I'm going to be using sine waves, and maybe we can get the grass to move kind of organically. To step through the Perl and noise values, we need a unique variable to do that. So any unique state that belongs to a blade of grass is going to go into an array so that we can keep track of them. So we need one for how it moves, or the rotational value, because we're going to rotate each segment of the grass. So we're going to make the grass one segment, add to the end of it a smaller segment, add to the end of it a smaller segment, until we get down to a certain length, and then we're going to stop making it. Each time we make a segment, we're going to rotate that segment a little bit depending on these noise values, and then that's going to give us the bending and curving of the grass. So it's tied to the noise wave. We need an offset for that, and that's what this array, this unique value for each blade of grass, is going to do. We're just declaring empty arrays now. We'll assign values to these arrays in just a moment. Our wave is just going to hold the return value from the noise. So inside the parameters of the noise, we're going to put in this r, this dot r off, and we're going to set the return value equal to this dot r wave. So one is creating the noise, the other is receiving the value of that noise. Our initial segment is going to start with a certain size, and then it's going to diminish as the blade is produced from its bottom larger size to its top end piece. So we need an initial length to start, and we need a way to diminish the blades over time. So we have one for our size of the segment, and we need one to tell it how much do we decrease the next segment. If you decrease it very little, you're going to have long blades of grass. If you decrease it a lot, say 75, the next segment is 75% of the previous one, then it's going to be short grass. So this is how we can get the length of the grass to vary. We don't necessarily want to mess too much with the size of the segment. We want to rather adjust the deprecation of it each time it's created and added to the segment before it. So that's what that array variable holds. Since we're going to be moving the X position, our loop is going to hold the X position. So it's moving from the right hand side or the left hand side of the canvas to the right hand side of the canvas. And each time it increments to the next position, that's where the next element in our array needs to be. Well, we're not keeping track of an index value in our loop itself. So one of the things I'm going to do is have a variable, an accumulator, that's going to keep track of the elements in the array as we are moving through its position in the loop. We'll call that this.index, so it makes it really clear. The next thing we need to tell the loop, how do we increment from the left to the right? Do we go by 10s, 20s, 15s? How do we do that? Well, it's going to be proportioned to the population, so we need a variable to hold our population. That's going to be this one. We have our arrays declared, we have our initial index value of 0, and we have our population of 150 blades in this patch of grass. Now we're ready to assign the values to those empty arrays. So let's do that with a loop. In our loop, we're moving from the left-hand side to the right-hand side, and we're going to increment or step our movements by a proportion of the population to the width of the screen. So to do that, we just divide the width of the screen by the population. The return of this, the results of this division, will give you that step value. So if width is 100 and our population is 10, 100 divided by 10 is going to return a step value of 10. So it'll go to 10, 20, 30, 40, 50. So that should make it pretty clear what's going on there. If that's too reductive for some people, I'm sorry, but sometimes breaking it down that way does really help crystallize it in a person's mind when they're still kind of, I'm not quite sure what's happening. So the next thing, or the first thing we want to do inside this loop is increment our index value. I think I probably should put this at -1 to start, and then when this happens, it will start at 0, because that's our first element in the array. It works either way. I'm not sure why. I'll have to look at that later. I'm going to test it later to see if it still works or if it works differently. But for now, I'm just going to leave it that way because this version works. The next thing we want to do is take this X position that's going like from 10, 20, 30, 40, or whatever it is. We want to take that value and we want to push it into the array. So we're using the .syntax push, and it's p5.js is going to look at the array and say, is it empty? If it is, let's put this value in there. So we need a unique set of noise values. So we're going to use a formula based on the element's index value to get a unique noise offset for that blade of grass. But it's unique and relational. So I could just pick a random offset value, but I want to use a formula instead because I want element 0 to be a little bit relational to element 1, to be a little bit relational to element 2, and so on all the way through the grass. So it looks like the breeze, if it's moving the blades, is passing over all of the patch of grass over time. So inside the push parameter, I have this formula here. So I'm taking the index number, whether it's 0, 1, 2, 3, and then I'm going to multiply it times the number. A very small number, so the offset changes slightly. And then I'm going to add to that result this base value. So all of the elements are going to have an offset that's at least this. If I multiply this .index times this value here, and this .index is 0, then this value is going to be 0. I'm adding 0 to this, so this becomes a base value. And then this is a multiple of this value here. So the offsets are slightly different, so you get this unique movement for each blade, but it's only slightly unique. The Perl noise keyword is going to return a value, and that's going into this array. It doesn't matter if the previous value is anything. It just ignores that. So we can start that condition with 0. So I'm just going to put 0 in that variable in the array there. And now we need to move to the size. This can be random because don't really need noise to tell what the grass is. It can be jittery in size. It doesn't need to be relational. So I can just put random numbers in here, but I want it to be constrained. I want there to be a minimum size to the grass and a maximum size. So that's what we've got there. You can play around with that and get a little bit more variety. And the last thing is the segment. This is how much the segment will be decremented or how much of the segment will remain after it's decremented when you move to the next segment. So let's say our first segment is 10, and then we move to the end of that segment to make the next segment of the blade of grass. We rotate it a little bit, and then we make it a little bit shorter. Well, how much shorter? Well, we want it to be a certain percentage of the previous blade. In this case, it's going to be 85% the size of the previous one. And then when it makes a new segment, that's going to be 85% of the previous one, and so on and so forth. This is the recursion. Eventually it's going to run out of length, and when it does, we want to fall out of that loop and move on to the next blade. So we need to give it an amount to deprecate by, or to remain at. 75 is a kind of we've mowed the lawn length, and then this 85 is it's out of control, and then 95 it's like it's a jungle and the plants look like they're attacking. So you can play around with that and get whatever effect you're trying to achieve, but that's how you would do it. We have all of our initial variables, our initial states, our arrays have been declared, and now they're filled with things by moving through this loop here. Next, we're ready to fill our update function, this method, with actually making the blade of grass. The very first thing we want to do inside this function is create a loop that's going to loop through all of our blades. Inside the loop of our index values, we're going to go through our arrays and start doing things with the values in there. I need a length that I can pass through into the recursion. I'm going to use a local variable for that. I'm going to get that length from the size array for this object. I'm going to be rotating segments of each blade of grass, so I want to encapsulate any transformations and rotations inside a push and pop. To make life easier, we're going to translate to the grass's position. We're going to make that the origin. Remember, its x value is contained in the array grass, and its y value can be fixed because it's on the ground. Here I'm going to put it in the middle of the screen, sort of, so I can see it better. But you would, if you wanted this to be at the bottom of the canvas, just take that part off there and put it wherever you want. This dot blade is going to be a function that we're going to send the length of our blade of grass into, and we're going to send into it its element, its index value. Which element in the array is it? And then we close that loop, and that's the end of update. And now we can make inside, we're still inside our yard function. We're going to make another function called blade, and it's receiving the length and the index value that we sent into it when we called it up there in update. Inside this function, this method here, I'm going to split the grass, the group of 150 blades, into two groups, and I'm going to use odd numbers for one group and even numbers for the other. And then I can do different things to each group and then put them together, and it's going to look like kind of layers of movement. So it's not going to look all robotic and sinusoidal and stuff like that. So let's do that here with the condition. So I'm just looking at the index value that I passed into it. If that's an even number, then this is a true statement, and it's going to do what's inside of it. So by a really small number, I'm going to increment this offset for the grass blade. If I use a big number, then the grass is going to turn on to itself and rotate into a spiral, and I don't want it to do that. I want it to just move very subtly back and forth, so we'll have to use a really small number for that. Still inside that condition, because this is what we're doing for one group or one layer of the grass blades. I want their color to be unique. Maybe they're drier, maybe it's a different plant or species, whatever it is, but they're going to be a different color. And I have this formula for the color here that's going to make them, I think, a brown color. And play around with the colors and have some fun with it. I kind of like variety. If you can change the shade slightly of each segment, it kind of gives it some variety that way too. So once we've got our stroke color, we're ready to get our rotational value. And I think I didn't declare that up here. I don't think I need to, but let's do that. Let's make a global variable called rotate. I think this could be a local variable, but I'm just going to do that for now because I don't want to mess anything up, because it seems to be working the way that it is. So inside map, the arguments inside map, I'm using the noise function inside the arguments of map, it's going to return 0 and 1. And remember, we're using the offset, this .roff, whichever element number that is going to be unique. It's returning a value 0 to 1, and we want to assign that to quarter pi. And then I want a fraction of quarter pi. So I'm taking the smallest available amount of pi as a keyword, which is quarter pi. I could take pi and multiply it times even a smaller fraction to get this amount, but I figured it's just easier to keep track this way. So 3/4 of a quarter pi. It's kind of confusing. And then that's the end of that condition. Let's bring this back up. So the rotation is really what's being affected by the layers. So right here I'm changing the color depending on whatever layer it is, and I'm using a different method for rotating it. I'm using noise. In the second state, the other layer, so if it doesn't equal, I could use an else here, but because I'm using lots of statements inside the condition, I'm going to keep it separate just so it's easier to see what's happening. So in this argument is if it's not even, so odd numbers, this is what's going to happen. So we have the same condition for our offset. You might play around with changing these values, maybe make this a little higher, maybe make this a little lower, whatever. Our formula for coloring it again, and I think this is going to focus on green, maybe. I don't know. I'll have to blank these out. I forget I've written this. I wrote this in March, so I'm kind of going back and trying to remember what are these colors. It looks like that's this is going to be at least 255. So this one looks like it's orange. So the odd ones are orangey brown, and the even ones are green. We're going to use a different formula to rotate. This time we're going to map not noise, but we're going to map sine. So we're using a sine wave, just moving back and forth. That's returning a different value. It's returning -1 to 1. We're going to map that to the same thing. I don't feel like typing all this out. There we go. Okay, so that's the second layer that's being colored and rotated. Now once we have our colors and rotations, we can come up with our strokes. And those are going to be uniform no matter what the layer, so we'll apply them generally. Our formula for the stroke weight is going to be a multiple of the length, and then we're going to take a fraction of that. You can work on your own formula for what you want the stroke weights to be, how they deprecate and change over the length of the blade. That's all workable, and you can get pretty sophisticated with it. Okay, the first thing we're doing is we're rotating the blade, and then we're drawing a line from where we started that rotation to the end of a given length. That's what this is here. And because we want the blade to grow upward, that movement is going to go negative or above the 0y position. The next thing we do is translate to the end of the blade. So now our origin is at the end of that blade, that section that we just made. Then we look at the length that we have available to work with. You can change this value here if you want the blades to be really small before they stop being made. Here 20 pixels is a pretty good end point to these. If you make it too small, it gets blunt at the end. It makes it look weird. So I found that 20 is pretty good for any size. If it's big enough, if it's not too small to work with, if it's big enough, then we're going to do a recursion. We're going to go back into the blade function that we're already in. We're going to send it the new length, which is going to be a multiple of the segment, the value that's in the segment part of this array. So remember, that was the 0.85%. So we're multiplying the length that we have times this 0.85%. We're sending it back into the function that we're already in. So we're going to make the blade again, or make the segment again, but now we're at the end of the last segment and we're a little bit smaller in our length, and we're just going to keep doing that over and over again until we fall out of this loop. So we need to pass into blade, the recursion, the same parameters that we did before, just changed them a little bit. So we need a length and we need an index value. Now it's going to perform that recursion, and it's going to keep doing it until it no longer can, and then it will fall out of that loop. So hopefully this is working. If I did everything correctly, maybe it's working. So we can see some grass here is curled up here. Let me move over so you can see what's happening. We can see that there's some really harsh curling going on. So it looks like I missed a 0 somewhere. Negative quarter pi, 0.75, 0.75. Maybe that's it. There should be an extra 0. So changing these variables, you can see the effects of that. The green layer is moving according to noise. And if you pay close attention to the orange, the second layer, the odd layer, it's moving according to a sine wave. So you can actually see the sine wave slowly passing through. If I increase the offset, it's going to move through a lot faster. And let's take a look at that. You can see the sine wave moving through. Now it starts to fall apart over time because of the unique offset starting value that I've given to each blade. So over time that sine wave starts to break up and it looks more kind of organic. My computer is really slow, plus I've got my recording software, so it's slowing things down even more, but you might have higher performance. You can use fewer blades and that would increase the performance. You can deprecate the blades by more, so instead of 85%, you might try 75%, because the less you deprecate them as you make them in the recursion, the more recursions occur because you have more length to work with each time. So that's going to increase or decrease the speed. It's going to increase the demands on your processor. If you like this program, let me know what you think. What would you do differently if you've typed along, if you've created your own? What kind of things have you done to your version that would be interesting for people to try as a challenge? I'd be interested to see that. So leave a comment if you watch this and happen to wait till the end. What else? Part 3. So I'm not going to do that in this video, but in part 3, I'm going to combine this grass with the previous video's fireflies into one graphic, motion graphic that has fireflies and grass moving back and forth. And it could be like a screensaver or some kind of motion graphic. I guess that's it for this video. Thanks for joining me. Do all the things if you want to see more. I appreciate the support. And as always, thanks for watching and take care.